Okay, well, before we go ahead and continue, just a few items. I'm hoping we should get really close tomorrow to finishing up the current lesson that we're on, graphing the other four trig functions. And then I'm thinking Friday would probably be a good day to go ahead, take the class period to work on those examples, just practice it. And then next week we'll go ahead and move on to the inverses. But what is happening next week? Your exam coming up on Friday the 7th. So about 9 days away if we're looking at it. So it's going to cover all this graphing material, and I did go ahead and throw a few extra law of sines and law of cosines problems on there as well. Remember, you can use your notes, focus activities, homework assignment, anything that you've ever written to go ahead and help you out during the exam. But that is going to be happening next Friday, and I believe that's all I got, unless anybody has a question. Okay, then let's take a look. Well, the other day, we went ahead and started looking at tangent. Okay, he has a y-intercept of 0. His period is going to be pi. And we had 5 critical values for tangent. Now, what does the no solution mean? That represented what on his graph? That was an asymptote. So for one period, we start with an asymptote, then have a -1, 0, 1, and then go back to another asymptote before it starts to repeat itself again. And yesterday we went ahead and did some examples of that. Okay, but let me go ahead and start to tie everything together for you here. If we're looking at graphing sine or cosine, what we're going to want to do when we create our compound inequality, we're always going to go ahead and put that between 0 and 2 pi. Okay. Now, each one of these, is going to have different critical values. Cosine has its maximum, 1, then we got 0, minimum, and then we keep going. Sine starts at a 0, then goes to a maximum. We just saw the critical values for tangent. But if you're trying to graph sine or cosine, to get the x values, you're always going to put whatever's in parentheses between 0 and 2 pi. Okay? But tangent and cotangent were a little different. If you're wanting to graph tangent, you're still going to have a compound inequality, but you're going to go ahead and use -pi/2 and pi/2, just like we did yesterday. Whatever's in parentheses, whatever's happening horizontally, is going to be written that way, okay, because those are consecutive asymptotes. Now, what you're about to find when it comes to cotangent, we'll review him in just a second. We're going to go ahead and put his compound inequality between 0 and, does anybody remember? Pi. Here we go. It's got to be between 0 and pi. Now, even when we go ahead and start looking at secant and cosecant today, you're going to see it's exactly the same as sine and cosine. In fact, I can go ahead and even write these right here. Cosecant and secant, you're going to go ahead and start them out the exact same way as well. It's only tangent and cotangent that the compound inequality boundaries are going to be a little different. Okay? So right now, we are currently on cotangent. This is the graph that we were looking at yesterday. We changed cotangent into cosine over sine. So wherever sine was 0, that's where cotangent was undefined. We had an asymptote. And we talked about, on the unit circle, how we get the grid here. And then we've got our little characteristics. Okay, I think we were just about ready to graph one of these. Is that right? All right. So at this point, we're pretty much caught up. At this point, pretty much caught up. Okay, yeah. Yeah, I'm here all week. Okay. Anyways, let's go ahead and take a look at A. I want to graph y equals cotangent of 2x. Okay. Now, here's the thing. We started this yesterday. Just like I showed you a moment ago, cotangent, whenever you want to graph him, his compound inequality will always begin with 0 and pi, because those represent consecutive asymptotes. Now, we put 2x here in the middle, but I have a question. I don't see parentheses. So how do I know that 2 is horizontal? It is directly connected to x, yes. Okay, anything else will be in the parentheses as well. Okay, if there was anything else, like if there was a +1 written here, then I have to believe that plus 1 is going up because there's no parentheses to tell me it's inside. Okay. Well, this one starts off with a pretty easy compound inequality. How could I get x in the middle? Yeah, here we'll just divide by 2. So if I divide by 2 in the middle, I'm going to do the same thing on either other side. So 0 divided by 2 is still 0. Less than or equal to 2x over 2 is x. And then we have pi over 2. Okay. So there's my compound inequality, just like we've been seeing with sine, cosine, and tangent. Now we're just looking at cotangent. Okay, so I'm going to put him to the side for just a second. Now let's bring up the critical values. Okay, let's revisit those. The critical values for cotangent, let's go from one period to the other. So see here, I'm going to start with an asymptote. So I have undefined. Well, I didn't even have them right here, but I'll just write them again. Now, as we're going through the points, what's the y value here? 1. Then I go to a what? What's the y value at this point? 0. And then this third point right here, the y value is -1. And then we finish up with another asymptote. Okay. Very, very similar to what tangent is. Remember, tangent is going to go -1, 0, 1. Cotangent is going to go 1, 0, -1. But it's always going to have an asymptote on either side. So this is what I'm looking at here. So asymptote, we said 1, 0, -1, asymptote. Okay, well, is there anything happening vertically here? Anything besides that 2 multiplied by x? Nope, there's no reflection. I'm not adding or subtracting anything. So that tells me these 5 values are going to do what? They're going to stay exactly the same. That's exactly right. Okay. So how am I going to make these y values, how am I going to pair them up with these x values? What do we always do? Now that's true. We are going to have to do that, but in just 1 second. Like this lower boundary 0, which of these 5 would he go with? Yeah, there you go. The lower boundary always, always, always gets paired with the first critical value. So the pi over 2, he's always going to go with the other one. The lower boundary is with the first critical. The upper boundary is always with the last. Now, this is what Nathan was just talking about. He said we have to find the distance. Well, how far a distance is it from 0 to pi over 2? Okay, so it is pi over 2, right? But what do we always, always do? We divide by 4. We always divide that distance by 4. So pi over 8. There you go. Now, will we always, always, always divide by that 4? Yes, once we know what that distance is. So pi over 8, what am I going to do? There you go. Starting with the lower boundary, I'm just going to add pi over 8 over and over and over again. Okay? So 0 plus pi over 8 is pi over 8. Okay? Yeah. And pi over 8 plus pi over 8 would be 2 pi over 8. As Nathan said, pi over 4. And then pi over 4 plus pi over 8 would be 3 pi over 8. Does anybody want me to actually take the pi over 4 and pi over 8? Excuse me. Can I actually show the addition of those? Sure. Okay. So if I wanted to take pi over 4 plus pi over 8, well, I need a common denominator. What would that be? 8, right? Okay. So I'd have to multiply this one by 2 over 2. So this would be 2 pi over 8 plus pi over 8. So once you have the same denominator, that stays the same. 2 pi plus pi, there's your 3 pi. Okay. And now we'd have to add 3 pi over 8 plus another pi over 8. And let's see. Let's check to see if that works. What's 3 pi plus pi? 4 pi over 8. But what's 4 pi over 8? Okay. It is pi over 2. Should it always, always match up exactly for that upper boundary? Yes, every single time. If it doesn't, that means we've made a mistake someplace. Okay? So these are my x's. So each of these individually are going to be ordered pairs that I'm going to graph. Okay? But there's two of these that look a little weird. Like we were talking about this yesterday. How would I graph a 0, comma undefined? That tells me where the asymptotes are going to be. So I have an asymptote at 0, and the other asymptote is pi over 2. Is everybody okay with that? Now the other three, we just go ahead and plot. So here we have pi over 2. So what's halfway between those asymptotes? That's pi over 4. So where's pi over 8? Halfway between 0 and pi over 4. So this one we're just going to have to kind of estimate. So it's going to be right there. That's pi over 4, but then we want to go up 1. Okay. And then we have pi over 4, 0, which would be right here in the middle. And then my last one, 3 pi over 8, well, wouldn't it be halfway between pi over 4 and pi over 2? But where am I going for him? -1. There we go. Remember, this method will always give you one full period on your graph. Okay. In this case, from asymptote to asymptote. Now, if I wanted to go ahead and draw any more, well, where would the next asymptote be? It'd be at pi. There'd also be one in negative pi over 2, and I could just keep going, right? Now, just copy this dot pattern in between every set. I know there's one right in the middle, one above, one below. One in the middle, one above, one below. And there you go. That would be cotangent of 2x. Okay. There we go. Now, your homework is going to have a little more on it, but all I'm going to be having you do is just sketch them. So when we get to the assignment, there's a few problems I'm going to have you omit. I'm not going to worry about it. Okay? I'm just wanting you to sketch these graphs. All right. So let's take a look at another one. Okay, we should probably be able to get one more done before we take off today. All right. So negative cotangent of pi over 2x plus 1. Let me go ahead and break this up first. Okay. We have horizontal. Okay. And then let's use blue. We have vertical. Okay. So let's go ahead and break this apart. So I went ahead and color coded it for us. What in this graph would be horizontal? What would be vertical? Okay, so Antonio says pi over 2 is going to be horizontal. Okay, so I've got horizontal in green, so I want to make sure that's horizontal. So you're saying what then, sir? Okay, so then he says this -1 and this +1 are vertical. Well, why can't I say that that +1 is horizontal, a phase shift? How do I know it's not inside? There you go. If it was telling me I did want that to happen, there would be parentheses there. Without parentheses, I have to believe it's vertical. Okay? So we can start however you like. Do you want to start with the compound inequality or the critical values? What's your choice? What do you want, ma'am? Compound inequality. So for cotangent, okay, we said less than, okay. Now for cotangent, we always put it between what and what? 0 and pi. Remember, both sine and cosine would always go between 0 and 2 pi. Tangent will always go between negative pi over 2 and pi over 2. In fact, Deborah, what am I going to put in between these? That's exactly right, pi over 2x. Okay. So now, we want to simplify this so that we have just the 1x in the middle, nothing else. So do you want to do this in one step or two? One? Okay. Now, if I want to do this in one step, I got to get rid of pi over 2 all at the same time. There you go. So Nathan says we got to multiply by the reciprocal. Okay. Now, if I'd multiplied by 2 and then divided by pi, would it still end up being the same thing? Yeah, if you want to take an extra step, there's nothing wrong with that. But now we'll distribute. What's 2 over pi times 0? 0. Less than or equal to 2 pi divided by 2 pi. Well, that's just the 1x. Now I'm going to have 2 pi over pi. That's going to write that. So that would just be what? 2. So this one was actually pretty nice to us. Our compound inequality lost the pi. And you'll notice what happened to the graph. Yeah, the graph is always going to fit the function that you have. Okay, it should always work out very nicely. Is everybody okay with how we did that? Okay, that's ready to go. We're going to put him to the side. Now let's go with our critical values. Remember, for cotangent, we're going from one asymptote to the other. But what was it? Was it 1, 0, negative 1? Or was it negative 1, 0, 1? 1, 0, negative 1. Cotangent was 1, 0, negative 1. Tangent was negative 1, 0, 1. Okay? And remember, we don't have to commit that to memory. You got your notes. Okay, you're going to be fine. All right? Well, what's happening here that's going to change those? Anything? Yeah, each of these we want to multiply by what? Negative 1, and then we want to add 1. Okay? Are there any of these criticals that aren't going to change? Yeah, the undefineds. Remember, nothing's ever going to change the undefineds. So they're still going to be undefined, right? So let's take that first value, 1. According to the function, I want to do 2 things. I want to first multiply him by negative 1, and then I want to add 1. So that's going to give me 0, negative 1 plus 1. Okay. All right. Or instead of negative 1, we'll probably say negative fun. Yeah, no. Okay. Second value, moving on. 0 times negative 1 plus 1. That would just be 1, yeah. And that's exactly right. Negative 1 times negative 1 plus 1. There we go. Okay. So is everybody okay with where I got my critical values and why I needed to change them? Okay. Now the originals, I'm going to go ahead and remove. These are my y values. Ooh, that was weird. Now again, how do I compare or link up the compound inequality with the 5 values I just got? Okay, so the lower boundary is going to go with the first critical. So I'm going to put 0 here. Upper boundary 2 with the last one, every single time. Now this one's going to be a lot easier, right? We're not dealing with pi. How far is it from 0 to 2? 2. So we know the distance, but we always divide by 4. So we're going to be adding 1/2 over and over again. There you go. So 0 plus 1/2 is 1/2. Plus 1/2 is 1. Plus 1/2, 3/2. Or if you want to go 0.5 and 1.5, that doesn't change anything. That's perfectly fine. Okay. Now, are there any questions on how we got these? Is anybody having trouble? Okay. Well, where are my asymptotes? We got one at 0, and we got one at 2. Okay. Let's graph the other points. So 1/2, 0, so 1/2, 0. Then I have 1, 1. And then I have 1.5, 3/2, 2. Okay. There you go. Well, see, that looks more like tangent to me. What made it curve upwards? Remember, the negative reflected it. It flipped it. Okay. Now, let's say I want to go ahead and draw another period of that. Where would another asymptote be? Yeah, the next one would be at 4. If you wanted to go in the other direction, you could say, negative 2. You'll notice they're always the same distance apart. Well, how am I going to draw the curve? Yeah, just follow the points. I know that halfway between, I got to go up 1. And then I got to go here and here. I'm just going to make the exact same pattern over and over again. Okay, here, here, and here. There we go. Okay. How are we doing? Okay. Now remember, for tangent and cotangent, the compound inequalities are a little different. lower and the upper boundaries, but the process stays the same. Nothing about it changes. Okay. All right, good. Well, I got 32. Let's go ahead and stop there. And then tomorrow, I can go ahead and show you these guys and how we get them. Okay. They're actually, again, they're not bad. They're not bad. These are actually pretty easy to graph. Okay. All right, cool. Do you want to save changes? Yes.